Hi everyone, Mr. G here. Now that we've talked about number operations, we're going to talk a little bit about Booleans. So on the left side here, you can see there's a Booleans folder. I'm going to open the markdown here and use our preview window to take a look at it. So Booleans, as much as it doesn't make sense that we have a lot that we could do with a true and a false, there is actually a lot of potential here. So the first is the concept of integer casting. So we're going to define two variables, a and b. One's true, one's false, just for us to be able to work with. Integer casting allows us to convert a Boolean value into an integer value to potentially do math with. And the conversion's pretty simple. True is 1, false is 0. So here, I use the int casting, so it's int parentheses, and you put your Boolean value inside. In this case, we have a variable representing the Boolean value. So int of a is true, so this value is going to be 1. And int of b is false, so it's going to be a 0. So we can see the output here. Int of true is 1, int of false is 0. It's one of the simpler ones, but if you ever need to convert a Boolean to an integer to work with or do math with, it's very helpful. Not is probably the simplest operator we have. We only have two options. We have true and false. And the not operation flips the value. So if it was already true, so not a is not true, which is the same as being false. So we see not true is false. And similarly, not false should be the opposite, which is true. So it allows us to flip a Boolean value if we ever need the opposite in some context, which is actually something that comes up with a decent amount of frequency. So and or is a little bit further down, are the two interesting operations for Booleans. They're a little more complex. So they both take two Boolean inputs. So we typically, you can look at the table and see I use P and Q. This is like a classic Boolean algebra. And it combines them kind of like addition or subtraction would and outputs a value based on their value. So the rule for AND is that AND's output is true if and only if, so only when, both inputs are true. And in all other cases, it's false. So if even just one value is false of the two, the whole answer is false. And we can see this here. So P and Q are different Boolean values, and they're distributed so that we have every possibility, both true, both false, P true, Q false, P false, Q true. We got all the options. So P and Q, you'll notice, is only true in this top row, where both P and Q were already true. In here, because Q is false, P and Q is false. Because P is false, P and Q is false. And because both are false, P and Q is false. So this would, in Python, we just use the AND keyword. So we would write A and, in this case I use A again to represent true and true. And it comes out correctly. True and true is true. In all of these other combinations, true and false, false and true, false and false, would all result in false, which mirrors this, what we call the truth table we had up here. So that's AND, only true if both are true. OR does a similar thing. It takes in two values, it gives us an output. But this time, instead of true if both are true, it's false only if both are false. So if there's even just one true somewhere, the OR will become true. So in a certain sense, it feels kind of like an opposite to AND. And you'll notice in the in the truth table, you see a similarity. AND only had one true value and the rest were false. OR only has one false value and the rest are true. So again, we have the same setup for P and Q here. And then P or Q is true as long as at least one is true. Here both are true, P is true, Q is true. These are all good. Down here though, we don't have a single true value, so OR would return a false. And just like AND, we do this with a keyword. We use the OR keyword. So A or A would be true or true, and that would result in a true. A or B, true or false, is still true. False or true is true. And finally, false or false is the only one that isn't true in this scenario. It is false. And again, if you want to play around with any of this code or get a better feeling for how these operators work, the Boolean operations.py file has all of the same samples that were provided in the markdown file for you to potentially play around with and modify. So now let's get on to our last type. We're going to talk about strings.